All right, let's do some math. Well, look who bothered to join us today. Welcome back. Are you feeling better? Or were you just playing hooky? Hooky's fine. You're an adult, you do whatever you want.
He feels tired, so he told us that.
Who's what?
He feels tired.
Is that what he?
Yeah. Jimmy was all like, "Aren't you doing today?" Hey, I want to say hi and goodbye to you. I didn't know that.
So we were doing inequalities. And just as a reminder, we'll do one where it's factored real quick.
Sorry, this is 1.7.
Yes, it's 1.7 still.
Okay.
This should look somewhat familiar to people that were just here. I'm going to expand upon that idea that we had. There's a lot going on here, but if we set each of these equal to 0, we're going to see we get x equals -5. 1 shows up as an answer twice, and 5 shows up as an answer 3 times. But we can't really do it more than once, so I'll just put down spots for -5, 1, and 5. We had a less than or equal sign, so we are going to have solid points on each of these. The equal portion says we're going to have solid points. And now we're going to break it up into regions. So I'll do the first one. I want you guys to do the rest. What you're doing is you're plugging -10 into each of the parentheses. And all you need is the sign. -10 plus 5 is -5, it's negative. So the first, all of them are going to be negative here. I should have 6 negatives here. And an even number of negatives makes this region positive. So I did that negative, it's that one right there. Go through and figure out how many signs, negative signs you have in each region. I use 0, 3, and 10 as test points. Go ahead and do it. Figure out how many negative signs, and we'll hit it in a second. You don't look like you're busy there. Neither do you, Jimmy. Laugh when I fucking target Luis. You're not over here working either. Fucking slackers. Yeah. We're gonna make it a little bit harder. Well, we did like 2. We did a quadratic equation. I souped it up a little bit. If I stick in 0, like all that matters is the number that's in each parentheses. I got a positive and 5 negatives. 5, -1, -1, -5, -5, -5. This reaches negative. If I stick in 3, x plus 5 is positive. X minus 1 is positive, there's 2 of those. And 3 minus 5 is -2, that's negative, so and there's 3 of those. This region's negative. And when we stick in 10, they're all positive. And when we did quadratic and we had the greater than sign, they look like they alternated. In general, they do alternate, but notice this didn't alternate right here. Going from one region to the next did not change signs. We wanted less than 0. Less than 0 is our negative regions, and that's these regions in here, and they're connected. So our interval is going to be -5 to 5. This will show up more later, and we'll see why it's happening this way when we graph these. But 1 and 5 are repeated roots. In fact, they'll even list the multiplicity. 1 has a multiplicity, which means how often it's repeated, of 2, and 5 has a multiplicity of 3. Multiplicity is an interesting word. It's kind of like long. It just says how many times the root was repeated. You will see for when you're doing these kinds of things, when there's an even number of repetitions, there is no sign change between consecutive groups across this critical point. Odd number does have it. We saw, even though 5 had a multiplicity of 3, it had a repeated root. It did change signs as we went across it. Multiplicity and stuff shows up in our later chapter. I think it's chapter 3. I think might be chapter 2. But while I was making this crazy, I thought I'd introduce it here because I can. And the reason why I didn't bother to do another quadratic equation, because we did a couple on Monday, is to remind you of this process, because we're going to do something similar right now with rational equations or rational inequalities. Variants just don't come no more. He gave us the big FU.
On Monday, he didn't come because he was taking care of stray cats. And I told him, "Are you coming today?" He's like, "No, it's like, no, my friend's on sick." I was like, "All right, stay."
Taking care of stray cats?
Yeah.
That is not a reason to miss school.
I thought we just want to stay your ass home.
Right, that's,
I was like, "Are you gonna join Zoom? Do you join Zoom?"
no. If you're gonna fucking just own it. Fucking stay home. I didn't feel good. I didn't feel good enough to waste my time coming to your fucking class. Right? Felt great for everything else.
To be honest about it.
I didn't want to come. It was, I was feeling a little down. Whatever. No,
The interval is it's positive, right? So,
yeah.
I thought I heard him say that again, I just. Sure.
Yeah, -5 and +5.
You keep messing up your negatives and positives, I think.
Well, I wanted to show you that it's okay to be wrong. You're gonna go through college a lot and find that you're wrong a lot. And a lot of students are so afraid of being wrong, they won't speak up. Jimmy, you know what I'm talking about. They're so afraid of being wrong, you won't throw out an answer. And I wanted, it's okay, it's okay to be wrong,
That's why it's the upside.
is that what it is? Sorry, man, got a little fucking, got a little bit of a tickle in my nose. Alright, so rational inequalities. So, example. 6 over x minus 3 is greater than or equal to 4. I'm gonna show you the right way rather than the wrong way. Everybody else will say just multiply 3 by x minus 3. That's not the right way to do it. We wanna get all the terms on one side with common denominator. So I'm gonna subtract that 4 over, bring it over to the left through subtraction. Greater than or equal to 0. And now to get a common denominator, I only have one denominator. I need to multiply this by, I need x minus 3 on bottom, so I need to multiply it by x minus 3 on top. And if I do, I get 6 over x minus 3 minus 4 times x minus 3 over x minus 3 is greater than or equal to 0. And now we'll make it one fraction. I'm going to distribute it at the same time. 6 minus 4x plus 12. Over x minus 3. So this is negative 4x plus 18 over x minus 3 is greater than or equal to 0. And I guess I could divide by negative 2. Factor out a negative 2, I get 2x minus 9 over x minus 3. And if I divide by negative 2, I get 2x minus 9 over x minus 3 is greater than or equal to 0. Okay, so then proceed like this is a regular inequality. But find critical points for the bottom as well. I divided by negative 2. Divide by negative 2 on both sides. Right side just goes to 0. Still 0, and the left side, they cancel out. No, but it changes the fucking sign. I divided by a negative, it changes the sign. Oh. Pull the James, is that better? I don't wanna say pull a Jimmy. I told my friends about that, and they thought that was fucking hilarious.
It goes easily change, I mean, change.
I got a little carefree divided by that -2, I should have done that. If Louise hadn't have said shit, I would have not changed the sign, I wouldn't have looked at it again. Alright, so 2x minus 9 equals 0. Gets me x equals 9/2 or 4.5 as a critical point. And x minus 3 equals 0 gives me x equals 3 as a critical point. Before I figure, I'm gonna put circles on both of them. Which of these circles should I fill in if any? We've got less than or equal to 0. We do not fill in both. There's a reason. When I fill it in, what does that say about the number?
Stops there.
It includes it.
Yeah.
It includes it. Can I include 3?
No,
I can't include 3. So the bottom always has hollow points.
But
Then the bottom would be 0. You can't divide by 0. Excellent question. 4.5 can be a solid point, or should be a solid point though. Now let's test our regions. I like using 0 when I can because it's so fucking easy. And I'm using them on 2x minus 9 and x minus 3. For 0, I got a negative over a negative, and I get a positive. That's a positive region. If I stick in 4, I've got 8 minus 9 is negative on top, and 4 minus 3 is positive on bottom. So I get a negative region there. And if I stick in 5, I've got 10 minus 9 on top, which is positive. 5 minus 3 on bottom, which is positive. This is a positive region. Some, if you will look online, they'll have you multiply through by x minus 3. It makes this a lot easier to do. There's like less hassle here, but it's really easy to lose the fact that x minus 3 is a critical point. They changed signs going across it. So it did matter. We needed to keep it. And it also shows that it can't equal 3. Not only is it a critical point, but it can't equal 3. We wanted less than that, so we wanted less than 0, so we wanted the negative regions. The negative region is between these. And so I have critical, or I have an interval of 3 to 4.5. 3 gets parentheses, 4.5 is a bracket. You guys want to try one? I'm not taking it all the way off this way, I know. Go fucking get grabby.
I'm ready.
You guys give this one a try. We did greater than last time, we'll do less than here. Less than or equal to 3. Really, please. You're 10 over 3 and what? Do the whole find the region?
Little graph.
Yeah. Did anyone else get that? Let's make sure everybody's on the right page for the next part. I'm gonna subtract the 3 over. And I'm gonna multiply by 2x minus 3 at the same time. So I got 3x plus 1. And then I've got minus 3 times 2x is minus 6x. And minus 3 times minus 3 is plus 9. Bottom is 2x minus 3. So I'm getting negative 3x plus 10 over 2x minus 3. Those, let's see. This should be positive. They're both positive. So now check the number line for them. 10 over 3 is 3 1/3, and 3 over 2 is 1/2 of 1.5. So this is like 3.3. Two is a good choice for the middle of them. 0 over here, and I don't know, 5 over there. That's loud. That's a good sneeze. That sounds like someone was calling bullshit on you again there. Did you just give me a pity laugh?
Yeah.
I'm just fighting words.
See if I can call it. So,
You're too calm. And I didn't show whether or not we fill anything in yet or not. No question stupid.
why would I be able to?
I'm sorry, what?
Why would I be able to?
Because if we said 2x minus 3 equals 0 and we solve, add 3.
Stupid question.
Not a stupid question, you're just trying to do it in your head. More pencil, less jibber jabber. Reese didn't do the graphing yet either, because he's not confident about doing it either. So don't let his swagger, I like his fucking, his moves like Jagger fucking attitude. Make you think that he's got it all under control.
The 10/3 shouldn't be negative.
No, it should be positive,
Why?
because if I do negative 3x plus 10 equals 0. I subtract 10,
Oh yeah. I still don't get like the one we were doing before, the like this plus, which one is negative and which one is positive.
okay, so. What you're doing is taking these numbers right here.
Mm-hmm.
And you're plugging them into negative 3x plus 10 and 2x minus 3. Whatever you have in parentheses, if there's a bunch of parentheses on top, you'll do each one separately. So we got some regions. If I plug in 0, 0 here gives me 10, which is positive. 0 here gives me negative 3, which is negative. A positive times a negative is a negative. This is a negative region. It doesn't matter that it was 10 and negative 3 and it gets me negative 30. Everything on this side of the 3 halves should be negative. I'm gonna do the same thing with 2. If I stick in 2, negative 3 times 2 is negative 6. Negative 6 plus 10 is 4. That's positive. 2 times 2x, or x is 2, 2 times 2 is 4, 4 minus 3 is 1, this is positive. So I've got 2 positives, that's a positive region. If I stick in 5, I've got negative 15 plus 10 is negative 5, so that's a negative. And if I stick in 5 to 2x minus 3, I have 10 minus 3 is 7, which is a positive. I've got a negative times a positive, I get a negative region. So that's how you're doing it.
Where did you get the 4 and 1 in the middle?
Negative 3 times 2 plus 10. I plugged this in right here for the x's.
Okay.
The same thing I did in each of the other zones.
Oh.
So
Okay,
you're
got
just
it now.
plugging you in into what you started with. I'm making it like it's not magic.
Okay.
That gets you to 4. All right. So we got it down, we saw that they're negative. And we want less than 0 are negative numbers. So we want to go that direction and we want to go that direction. Which one do I fill in and which one do I not fill in? I can fill in the 10 over 3. Can I fill in the 3 over 2? Why not? It's the bottom one. So the bottom can never equal 0. So that's why we don't give 3 halves any credit there. If we're doing interval notation, we've got negative infinity, and we go up to 3 halves and we stop. 3 halves is not included, and neither is negative infinity. We continue on with our little pin going along, we hit 10/3. We start again, and it goes all the way to infinity. And we're including 10/3, but we don't include infinity. Since there's 2 regions, we use a U. All right, now we're gonna start 1.8. (1.8) is on absolute value equations and inequalities. So we got 3 cases, I'll just start with the basic version here. Absolute value of x equals k. Absolute value of x is less than k. And absolute value of x is greater than k. And we'll look at solutions for each of these. If I stick in k or negative k, I solve the first equation. In fact, those are the critical points for all of these right here. Here, x equals k is only these 2 points. We don't do any shading, there's no arrows, it's just those 2 points. The less than, since it's not an equal portion, we have hollow circles. And it makes a sandwich. So let me label them A, B, and C. B can be rewritten as negative k is less than x, which is less than k. What I did to do that is I started with absolute value of x is less than k. I kept it as is. And then I flipped the sign and changed the sign there. And then I saw I can rearrange these two into that. So you keep one the same. And then you have a flip. Flip the signs and the inequality. You can see if I rearrange them and put negative k on the left of x, I would have negative x is less than k, or x, negative k is less than x. And then I still have x is less than k, and so it kind of makes this sandwich thing. Sandwich. If I do that with x is greater than k, I keep one the same. And then I flip the sign and flip the inequality. We don't ever want to do this. Don't do this. Don't try to say negative k is greater than x and x is less than k. This is completely wrong. And you're going to lose quite a few points for it on the test if you do it. They don't go together. You can't do that. So I can't make a sandwich out of them. This just ends up being an or situation. X is less than negative k, or x is greater than k. So we're going to have 2 regions here. Well, the way I remember it, this is gonna sound fucking lame as fuck, but it's how I do it. Less than sounds like and. It's fucking lame. Greater sounds like greater. Yeah, I told you it's fucking lame. But it works. Fuck, it works every time. I don't need to switch to, I don't need to do this, like, flip the sign thing, because I have this stupid. Sound relationship going on. You can do this thing where you do the same and then you flip the sign and the symbol. That will work no matter what you do, but putting them together, like some people will try to take these. And make that, and that's a no. You can't force them together like that. The symbols gotta go in the same direction. They can both point to the left, or they can both point to the right. But they gotta go in the same direction. That's the general rule of thumb for this. I'm gonna add one little bit of caveat to it. If you've got an inequality on both sides. Like I have absolute value of X is less than absolute value of A. We're still gonna do it, even though there's two absolute values. We're still gonna go X is less than A. And X is greater than negative A. Which would put this together to make negative A is less than X, which is less than A. Those go together fine, it's a less than, so it's a sandwich. But even though there was two absolute value signs, we do one where it's positive, one where it's negative. Now let's go on to actually doing equations. 9 minus 4x absolute value equals 7. You have to solve this two ways. Do we do 9 minus 4x equals 7? Or 9 minus 4x equals negative 7. There's no inequality to flip, but we still flip the sign. Go ahead and solve those real quick. If x equals 1/2 or x equals 4. So that's the key to these absolute values. We keep one the same and we change the sign on the other. If there's an inequality, we flip the inequality as well. This also holds true if there's an absolute value on both sides. This will turn into 3x plus 2 equals x minus 5. Or 3x plus 2 equals negative parentheses x minus 5. So give those a solve. So I move the x's to the left. Get 2x equals negative 7. So x equals negative 7 over 2, or this becomes negative x plus 5. So I will add x to both sides, subtract 2, and you get 4x equals 3. Divide by 4, and I get x equals 3/4. All right, let's take a 5-minute break. Give everybody a little stretch. It's been an hour. Been tormenting you long enough. All right, let's look at the inequalities ones. Let's do absolute value of 4x minus 6 is less than 10. The less than turns into a sandwich. You can do it, go slowly, do 4x minus 6 is less than 10. And 4x minus 6 is greater than negative 10. Or when it's the less than sign, you can jump straight to doing negative 10 and 10, keeping the inequality the same, and putting 4x minus 6 in between them. The less than is the sandwich. And we did triple. Equality or triple inequality the other day, whatever we do to one side, we gotta do to all sides. If I add 6 to get it out of the middle, I gotta do it everywhere. Divide by 4 and I get -1 is less than x, which is less than 4. And if you did that on a number line. See, it does this. And so in interval notation, we've got -1 to 4 like that with parentheses on both sides. Why don't you guys try one real quick? If you're done writing, so it looks like you're ready. Make the sandwich. Add 3 everywhere, I get -4 is less than 2x is less than 10. Divide by 2. And I get -2 is less than x, which is less than 5. And in interval notation, that is -2, 5, parentheses. Ready for another? Now try a greater than 1. 3x minus 8 is greater than, oh, I don't know, 7. Greater is an or. So when you split it, it just makes 2. You keep the greater than 7 on one, and then you do less than -7 on the other. change the sign and change the inequality. So I'll add 8 to both sides on each of them. Get 3x is greater than 15, or 3x is less than 1. Divide by 3. I get x is greater than 5, or x is less than 1/3. On a number line, 1/3 is close to 0, 5 is definitely a lot higher than that. And we want greater than 5 or less than 1/3. So interval notation will be negative infinity to 1/3 in union with 5 to infinity. 5 to infinity. That's not infinity, that was an 8. All right. Not too bad, is it?
I just want to ask something, because some of these also can come like prime, no? Or I'm wrong. Like,
What do you mean they can become prime?
like if the 7 is negative, depending on the arrow which side is pointing, left or right, it can become prime. I remember something like that.
I don't know what you mean by prime, but I think I know where you're going, just wait for it. We're
Okay.
getting there. All right, you guys ready for more? Let's kick it up a notch. Let's do 5, absolute value of 5 minus 8x. We'll add 6 to it, and that will be greater than 14. Give that a try. Alright. Subtract 6 from both sides. The absolute value of 5 minus 8x is greater than or equal to 8. So this turns into two forms. 5 minus 8x is greater than or equal to 8, or 5 minus 8x is less than or equal to negative 8. Subtract 5. I get negative 8x is greater than or equal to 3, or negative 8x is less than or equal to negative 13. Divide by negative 8, divide by negative 8. We divide by a negative, gotta change this inequality. Change this inequality. So we have negative 3/8 and 13/8. And it was set to be going greater than on the left side, but now it's less than. So we want less than that, and we're including it, so we'll fill it in. And we want greater than 13/8, so we'll fill in on that one too. Negative infinity is less than negative 3/8. In union with 13/8 to infinity. So don't forget, if you divide by a negative, you gotta flip the sign.
Wait. Let me take a picture. I'm done.
Eric's not there. Couple other people are right too. How's Josue doing? You guys aren't. It's inconceivable.
Huh?
Inconceivable. That's a good movie if you haven't seen it. Alright. Alright. So what about this? Alright. So you got 6x minus 9. It's greater than -2, or 6x minus 9 is less than 2. Add 9 to both sides. This is 6x is greater than 7, or 6x is less than -7. Nope, it's positive 11. Learn to fucking do your math there, David. Divide by 6. And get x is greater than 7/6, or x is less than 11/6. If I do greater than 7/6, it's this way. If I do less than 11/6, it's this way. The or normally does this, doesn't it? The or, the great or did that. What does it mean now that we're across? It has to, the number has to be greater than 7/6, or it can be less than 11/6, which literally means it could be any number. X can be any number. There was a way to notice this ahead of time. We had absolute value of 6x minus 9 is greater than -2. What do we know about absolute values?
Positives.
They become positive. So, whatever I put in here, I'm gonna end up with a positive number when I'm done with the absolute value sign, right? This is a positive number greater than -2. That's always true. And I didn't have to solve for x. So what Josue was alluding to earlier is when you've isolated the absolute value. If the right side is negative, I guess I should say other side. We have special cases. So pay attention for them. Let's look at the other options for special cases. What if that said absolute value 2 minus 5x or 2x is less than -8? We have a negative on the right side, so let's reason out what's happening here. Save yourself some work and do some reasoning skills. This is always a positive number. And so this is saying a positive number is less than -8. That's never true, is it? So no x solves this scenario. Solution does not exist.
No solution.
Correct.
So fix it equal to.
That's because the negative cannot be bigger than the positive. That's why.
Correct. Say, ask again, Luis?
Because it's equal to, that's why it passes.
No, it's because it's less than.
Got
Oh, that equal to is also true. A positive number can never equal -8. There is not a single positive number that equals -8.
Or would it be if the top of it?
Say that again?
Like the 6x minus 9 is greater than or equal to negative. What's the
Same true, same situation. It's a positive number. We make it greater than or equal to. It's a positive number, it is always greater than or equal to -2. The equal to portion is obsolete. Because it's never the equal portion. But there is, it will always satisfy the greater than part. That's a good question. That was a good question. And now if we just had 6x minus 9. Absolute value, and we said equal -2. This is again, a does not exist DNA solution. Josue, you were thinking prime. What you're thinking of when I said you're saying prime is
Like
that
prime
when
is-
you
Yeah.
when you
Sorry.
when you try to factor.
Okay.
If you can't factor, you might say that there no solution exists.
Yeah.
But that was like. For doing that, like if you couldn't factor anything out, it was already prime. So there was nothing to factor out, was prime. In a situation like this, there's either a solution or not. Prime doesn't apply. Prime just means there's no two things that multiply together to make it.
Oh, okay then. Yeah, what I mean is yeah, I didn't use the right word. It was like something
Right.
like I just said in special case. Yeah.
Yeah, special case is a better scenario. Yeah, there is another special case. Equals 0. Every other absolute value is split into 2. We did a positive version and a negative version, but there is no fucking positive, negative, 0, so it's just one equation. When it equals 0, there's only one solution. X equals 6/3, which equals 2. Just a single solution. We got a little bit more on this. How does this stuff apply to real life? Like, this stuff actually is useful. We use absolute values to model distances. And tolerances. So if like we're on a number line and I've got like the number 2 here. And I want to say X is within 5 steps of 2. Or 5 numbers of 2. I'm saying that I can go 5 that way or 5 that way. We would do X minus 2 absolute value. This represents the distance between some number X and 2. If it's within 5, that distance is less than 5. Well, I'm gonna say less than or equal to 5. One you're very familiar with. The average human body temperature is 98.6. Our temperature T, we'll call our temperature T. We are not feeling well if we are more than 3 degrees away from that. So we model how close our temperature is to whatever your neutral perfect body temperature is. Not everyone's 98.6, but everyone has a body temperature that's theirs. When you get more than 3 degrees away, either colder or hotter, you don't feel very good. So whatever that distance away is what goes outside the inequality. The distance part is between us and the temperature, 98.6. And we're saying we feel sick, we are ill or sick when we're more than that would be greater than. So this can model temperature ranges for things like that. You're putting together your motorcycle, you got a Harley Davidson. You like putting that shit together. You need a nut that fits one of your screws on the bike. Not screw bolt. For your Harley. Let's say the bolt is, what's an average good width? 5/16 of an inch. The bolt is 5/16 of an inch. The nut needs to be. Let's go with 1/32 of an inch. Of that size. For the threads to hold. So a little bit bigger, it'll still hold, it's not like super tight, but it'll hold. And then if it's a little bit smaller, you're fucking grinding that shit in because it's fucking hard. Doesn't quite fit just right. So you have to kind of like force it in. We want our bolt. Is the distance between our bolt's width, not our bolt, the nut's width. And 5/16 of an inch. Needs to be less than 1/32. It's got applications, absolute values, inequalities is pretty useful in real life. I'm gonna call it here. That's the end of chapter 1. We will start chapter 2 on Monday, and I gotta adjust the time scale a little bit. More tinkering with the syllabus. when I first designed this, I didn't really give a lot of time. There's a lot of shit to go through in this class. But like, so it's kind of, I wasn't giving a lot of time for students to do practicing class. And I've been trying to do that more, and it fucking slows down my teaching. To the point where like, I gotta fucking edit the schedule. I can't do it as much in the future anymore, I gotta. Like, we're missing some content this semester at the end that you'll see in like. Later courses, so it's not the end of the world. But